What is bioflock shrimp farming and how does it work? Most shrimp farming is done in outdoor ponds that depend on the sun and a robust algal community to process the nitrogenous wastes from the shrimp and to supply oxygen to the pond water. The shrimp also pick up some essential nutrients from the algae, creating a nifty arrangement, but a difficult relationship. Blame the algae. It blooms, it crashes, it takes the day off when it's cloudy, works against you at night, and has days when it just does its own thing. Picture 10 identical shrimp ponds, all in a row. Each will have a slightly, and sometimes dramatically, different algal community, leading to wild swings in water quality variables that slow shrimp growth and create endless management problems for the shrimp farmer. Bioflock shrimp farming encourages a bacterial community in the pond. Once established and maintained, bacteria-dominated ponds are more stable than algae-dominated ponds. The bacteria accumulate in clumps called flocks, more about flocks in a moment, and gobble up the nitrogenous wastes 10 to 100 times more efficiently than algae. They work night and day, pay little attention to the weather and turn those nitrogenous wastes into high-protein feed for the shrimp. Bioflock shrimp farming works anywhere. In the tropics, in temperate climates, in the desert, close to town, in buildings and in greenhouses. It promises to revolutionize shrimp farming. Amazingly, almost all the equipment and know-how for putting together a bioflock shrimp farm are available right off the shelf. The problems is that it takes tens of millions of dollars to make it work and operating costs are high. Here are some of the pieces you need to put a bioflock shrimp farm together. Filters to exclude disease carriers from incoming water. Reservoirs and settling ponds for treating water. High stocking densities of disease-free, genetically improved shrimp, like Peneus vaname, that graze on naturally occurring organisms in the ponds. Recycling of water within the farm to remove sludge and maintain desirable balances of nutrients, algae and bacteria. Zero water exchange with the environment. Biosecurity to keep diseases out. Lots of aeration and mixing of pond water. Pond liners. Sludge removal from center drains. A good source of inexpensive carbohydrate molasses, wheat to stimulate a bacteria-based food chain. Greenhouses are buildings to keep temperatures above 30 and deg.C. A laboratory for diagnosing disease and assessing water quality. In this case, the whole really is greater than the sum of its parts because of the magical relationship that develops between the microbial community in bioflock ponds and the shrimp. Unlike flow-through ponds where algae dominate, bacteria take over in these ponds, aggregating in microbial flocks that also contain fungi, protozoans, algae and nematodes. A veritable shrimp feast. The flocks process nitrogenous wastes, and the shrimp feed on the flocks, a symbiosis that stabilizes water quality and supports rapid shrimp growth. These ponds teem with tiny little critters and shrimp are the top predators. They are in heaven. The technology requires lots of aeration, some adjustments to local conditions, and you have to prime the pond for bacteria by adjusting the carbon-nitrogen ratio in the pond, but once the bacteria take over, the pond mostly takes care of itself. Because the shrimp pick up a lot of nutrients from grazing on the flock community, feed costs drop and so do the labor costs associated with feeding. These ponds produce 10 times more shrimp than semi-intensive ponds and 40 times more shrimp than extensive ponds. When covered with greenhouses or housed in buildings, they offer the only real option for stopping viral diseases. And if that doesn't get you excited, they have almost zero impact on the environment. Yup, it sounds almost too good to be true, but it appears to be working, and shrimp farmers all over the world are assessing its potential.
For more informative videos, please subscribe our channel.